Hello, assalamu alaikum. Can you hear me? Hello, can you hear me? Hello. Hello. Hello, can you hear me? Hello, can you hear me?
Yes, sir. Here was some internet issues.
Hello.
So that's why. Yes, sir. I listen.
Okay, can you hear me now?
Yes, sir. Yes, sir.
Okay. So I share my screen.
Recording in progress.
And I already started to work with your project. Can you see my screen now?
Yes, sir. Yes, sir.
So, okay. So mainly
Yes.
after starting this code, first of all I also try to show you my own area of interest and discuss all of this code, then move to this code so that you can easily understand. And after getting all of the things, then you can just simply get from here the training point. Okay, and how you can collect the training point, I also try to discuss about this in this time when I will show the practical things so that you can easily understand. And okay, let's start. So I open my slide.
Okay, sir.
So hi and welcome to the third test training session, advanced level on Google Earth Engine for remote sensing analysis. So I am course conducted. So in this time today, this is our full course content. Okay, and today in this third day course content will be that I also discuss about the how to make land cover classification chart. After you can make the land cover classification for any region, you want to make the land cover classification individual area or a specific area, how many built up area or how many vegetation or how many bare land will be available in your particular region, and you want to show present this area as a chart. Okay, as a bar chart or column chart. Okay, I also try to show you this part. Then calculating the LULC classification area. Suppose you want to calculate any classified area, how many bare land or how many build up area or how many vegetation will be available in your specific region. Okay, you can also easily calculate it. Okay, then how to add the legend. Suppose you want to add the legend in Google Earth Engine platform, so you can also add the legend in Google Earth Engine platform very easily. And how to make LULC map using machine learning. So in this time I also try to discuss about the different types of classifier. Suppose I also try to discuss about the support vector machine classifier, then classification and regression trees, then also discuss about the minimum distance. Okay, and also discuss about the random forest classifier. Okay, so that you can easily understand about the classifier and you can easily use this classifier for making the land cover classification map using the Google Earth Engine platform. Okay, so let's start.
Sir.
So first of all, in this time I also try to show you these practical things using the Sentinel-2 satellite imagery, and this is the same way for the Landsat. Okay, just it's different, some different about their band. Okay, and we can also easily use the Landsat satellite imagery for a long period of time, but Sentinel-2 satellite imagery for you can observe the land cover classification very short time. Okay, but your project I also write this code in Landsat. Okay, so that your project will be start from the year of 1991. Okay, 1991. Okay, it will be start from here, so that I will use here the Landsat satellite imagery. But in this time I also try to show you also the Sentinel-2 satellite imagery, how you can easily make the land cover classification map using the Sentinel-2 satellite imagery. Okay, and you can also make the map like this with their legend. Okay, so mainly in this time here I use the built up area, water body, vegetation and bare land. Okay, and okay, so let's start. So first of all, so we also try to complete this thing using the in our area, then move to the chart. Okay, how you can easily make the chart like this, how many area will be available for the built up, water body, vegetation, bare land, or how many class you want to classify it. Okay, you want to make the chart like this. Okay, so let's start. So I simply open my code editor, and I also send you this code for you also get the training point. Suppose you want to know better than me about their place, where the vegetation, where the snow. Okay, so just you can take the training point, then move to the other work. Okay, so in this time here I just use here your ROI, and I'll take the image classification or imagery. So in this time, okay, so I also add here. So we also work the letter. So first of all, we also complete our project for the land cover classification using Sentinel-2, then move to here. Okay, okay, I open a new code editor. So okay, so can you hear me?
Yeah, yes, sir. Hello,
Okay,
sir.
can you hear me?
Yes, sir. Yes, sir.
Okay, so okay, let's start. So we will start our session. So first of all, yeah,
I want we can do this on Landsat 5 because
okay, and you can see I also discuss about this, no problem, about the Landsat
Okay,
5.
okay,
You can
sir.
see here, we also add here the Landsat. So mainly you can see your you can use here the Landsat 5, Landsat 7, Landsat 8. Okay, for get the
Okay,
better imagery, no problem, because we also work with this, no problem. First of all, I will just show you a demo project so that you can easily understand for all of the code in here. Okay, so that
Okay, sir.
I hope
Okay,
it will
sir.
be better for you. Okay, so let's start. So first of all, you need to selecting your ROI. Okay, so suppose in this time I want to make the land cover classification for my this area. Suppose I want to make the land cover classification for this area, Dhaka city. So you can see, and your area is the big or small, it doesn't matter. Okay, when you want to take the big area, then you need to add here the more training point. Okay, when you want to use the big area, then you need to add here the more training point for your better accuracy. Okay, but when you work with the small region, then yeah, it's not mandatory for the large number of the training point. Okay, so it's remember that, and all of the process will be same. Okay, so first of all, I simply import my image collection. I simply click to the import. It will be imported my region of interest. You can see it will be table. So I simply change the name. I can give the name is the ROI. Okay, in this time I use here the Sentinel-2 satellite imagery. So in this time I just imported here my satellite imagery. Suppose I simply search here the Sentinel-2. Okay, this is Sentinel-2, and in this time I use here the Sentinel-2. I want to use here the surface reflectance. Okay, so multispectral instrument. It's not. So it's not. So our collection is that. So this is the, okay, this is our collection. You can see this is the Sentinel-2 multispectral instrument level 2A. So in this time I use this satellite imagery. So I simply click to the import, or if you want you can simply click on the collection snippet. So I simply click the collection snippet and paste in my code editor. After this I just put here a variable name. Suppose in this time I can give the variable name is that dataset. Okay, dataset. And you can see here just I use here this name, and now I want to filter. I want to make the land cover classification. Suppose my observation date is that, I simply use here the filter date. Okay, and my observation date I simply put here the year of 2021. Okay, 1st January, and it will be in 2022 1st January. Okay, so I can get from here the year of 2021 satellite imagery, and then I also use here my filter bounds function. Okay, and filter bounds function, it intersecting with my collection with my ROI. Okay, I simply use here the filter bounds function. After this I also use here the filter. I have this image properties, so I simply use here the filter. Then I simply use here the earth engine. How I can filter? I want to filter it if earth engine filter, then less than equal, I want to use here the less than equal cloud pixel percentage. So I simply, you can see I use this collection. So I want to simply go to the image properties. I simply copy this cloud pixel percentage. What value I need? I want to get the imagery which image will not be more than cloud pixel percentage is that 10%. So I simply use here the cloud pixel percentage. Then I simply put here my value 10. Okay, so now it will be okay. So in this time when I run this code and show my image, I can get some cloud and haze. Okay, so for this you also need to use here the cloud max function, so that's why you can get totally clear image. Okay, so for the cloud, when you want to remove the cloud, okay, so I also try to check my image, then I use here the cloud max function. Okay, so that it will be better. So I simply use here the map dot add layer function. Okay, and then I simply call my dataset and paste here. After this I also focusing my center of this map. I simply use the map center object. Okay, it is the ROI and zoom level 10. Then click to the run. So now I can get the imagery from here. You can see I can get totally this image as a tiles because I did not use the clip function. Okay, so here you can see I can get this image, and in this time I also want to add here the visualization parameter. Okay, so for this I use here the, simply click to here, and I suppose I want to show here the red, green and blue band, true color composite. Also increase the stress 98%. Then click to the apply. Okay, so now I can get my imagery. Okay, I also import this line of this code. You can see a new line of code will be added here. I simply copy this code and paste here after my object name. Okay, so now you can see here this is my imagery, which imagery I can get between this time period. Okay, and in this time you can see this imagery has some cloud or haze. Okay, so you can see this portion. Also zoom this level. Okay, you can also see some white haze, you can also see here. Okay, so now when you can also see some cloud in this image in here. Okay, so now I want to get clear all of the cloud and haze from my satellite imagery. So that's why this imagery will be looks good and we can easily get the better accuracy map. Okay, so that's why when you want to make the land cover classification map using any satellite imagery, first of all you should use here the cloud max band, so that this cloud max band remove all of the cloud and haze from your satellite imagery. Okay, so I use this in this time. And then I also make the land cover classification for my region of interest, Dhaka city. Okay, so for this, first of all, I will find what is my cloud marks band. Okay, just I want to find it. So I simply go to my image information sheet. So this is my image. I use this image multispectral instrument. I simply click to here, and here you can see, simply click on the band, and here you can see different type of band will be available here. And in this time I use here the cloud marks band. Okay, so here you can see this is the cloud marks band. Okay, this is my cloud marks band, and this cloud marks band name is the QA60. I just using this band for removing all of the cloud and haze from my salary imagery. Okay, and you can also see this QA60 band has the 2-bit marks. So first bit is the 10 and another bit is the 11. Okay, so this is the clouds and another is the cirrus clouds. Okay, so now I want to use the 2-bit for removing the cloud from my satellite imagery. Okay, so let's start. So first of all, I just simply copy this band name from here, and then I just simply make a function. Okay, and we already know about the function, how you can easily make the function. Okay, so I simply use here the function keyword. This is my function keyword, and after this I simply put here my element name. Okay, after the function keyword, you use here the variable name. Suppose I use my variable name is the marks to clouds. Okay, I simply use here the marks to clouds. You can use any variable name. After this I simply use here the parenthesis. Okay, in this parenthesis I simply use here my element name. In this time I want to work with the image, so I simply put here my element name is the image, IMAG, image. Okay, so you can see this is the function keyword. After the function keyword I simply put here my variable name, and after this I simply put here my element name. Okay, and I will all of the work using the element image. Okay, when I write this function, then I can simply use the map function for adding this function with my whole collection data set. Okay, so in this time I just simply use the function keyword. After this use here the variable name of this function. After this I simply use here the element name, and then I simply use here the curly bracket. Okay, and in this curly bracket I just put my argument what I need. Okay, okay, so first of all I want to select my cloud marks band. You can see my cloud marks band is that this is my cloud marks band QA60. Okay, I want to select this band. I simply copy this band name, and after this I take a variable in here. Suppose this variable name is that, I simply put this variable name is the QA. After this I call my element name image. Okay, I simply call the image and simply use here the select function. After the select function I simply put here my band name QA60. Okay, and then bits 10, you can see this band has the 2-bit. This band, I also try to show you that this band has the 2-bit. You can see bit 10 and bit 11. So bit 10 and 11 are cloud and cirrus respectively. Okay, so I simply select all of the 2-band or 2-bit also. Okay, so for this I simply take a variable. Suppose first variable is that I simply put this variable name is the cloud bit marks. Okay, and then I simply call here the bit number. Okay, 1, and it will be less than 10. So 10 is the bit number, and then another bit number is the 11. So I simply call here the another bit variable name is the, I simply put here the cirrus. Okay, cirrus bit marks. Okay, I simply use the bit marks. and after this I use the same way, 1 less than 11. So I simply select the bits 10 and 11 are clouds and cirrus respectively, and then we need to use the both flux should be set to the 0. So now I want to just set to the 0. Okay, so 0 means it's indicating the clear condition. Okay, so 0 means it's indicating there the clear condition. Okay, so I simply select my 2 bit max, cloud and cirrus. Now I indicating set here to the 0. Okay, so that's why it will be indicating there is the clear condition. Okay, so now I simply use here this another variable is that suppose max. Okay, and then I simply call my image, so it's a band name, so you can see it will be stored the QA band. I simply use here the QA. I select my call my variable QA. After this I simply use a function, this function called the bitwise AND. Okay, I simply use the bitwise AND function. So bitwise AND, so it is the small case bitwise AND, and after this I just simply use here my cloud bit max. So this is the cloud bit, I simply put here. I set here equal to 0, so I simply use here the equal to 0. Okay, after this I also want to add here the cirrus also 0, so I simply use here the AND function, and I simply call my QA band. I simply use here the QA variable name. After this I use this function is the bitwise AND, and after this I simply call the cirrus bitmax. Okay, and I also set here the cirrus bitmax equal to 0. I simply use here the equal to 0. Okay, so now you can see here, first of all I simply select my band QA60. This is the cloud max band. This band has the bit 10 and 11 cloud and cirrus. I also select this the 2 bit. Okay, and then I simply use here the 2 bit set equal to 0. It indicating the clear condition of these images, so that I simply use here the equal to 0, cloud bit max equal to 0, and cirrus bit max equal to 0. Okay, so indicating this is the indicating the clear condition. Okay, so now I want to use here the return image, so I simply use here the return function. I simply use here the return, and after this I simply call my element name is the image. Okay, and after this I simply use here the update max function. So I simply use here the update max. Okay, and update max I just put here my variable name, you can see max. So updates an image max all the position where the existing max is not 0. Okay, so in this time I simply set here the equal to 0. So I simply copy this max. Okay, and paste here. So here you can see already max. Okay, so now you can see here I make this function. Okay, so now I want to add this function. I want to add this function with my whole collection. This is my whole collection. I want to add this function, so that I want to add this function with my whole collection. Okay, so for this you need to